So, what kind of factoring is this numerator right here? Who remembers?
A times C.
A times C. Don't talk with your hand over your mouth. All right, so what are my factors?
Oh, I know how to do it.
It is.
4 and 2, but I want you to say x plus 4, x plus 2. Okay? So yes, x plus 4 and x plus 2. Okay? Now, this denominator, who remembers what that is? Yes.
X minus 4 and x plus 4.
Right, but what was this called?
Forget.
Difference between two squares. So everybody should be writing that down. Difference between two squares. But you were right in saying x plus 4 and x minus 4. Are there any questions?
For the first one, we didn't have to do like x squared, like the top part. We didn't have to do x squared plus 4x and 2x.
No, it's A times C factoring. All right, what kind of factoring is this numerator here? It's what you used to do back in middle school. GCF. What can I pull out of here?
3x.
3x. I pull out 3x. What's going to be left in the parentheses? X minus 3. What kind of factoring is this denominator?
A times C.
A times C. What are my factors?
X minus 3. X minus 3 and x plus 3.
Excuse me?
X minus 3 and x plus 3.
No.
That'll make
Multiply, you get negative.
And when you add, you will not get negative 1. So what does that have to be? X minus 3 is right.
Plus 2.
Thank you. Plus 2. Very good. Now, what cancels out?
X plus 4. X subtract 3. X plus 2.
Very good. And what's left?
3x over x subtract
3x over x minus 2.
Yep. Very good. Any questions going once? Any questions going twice? Okay. Next one. Not all of you got this, so please pay attention. Okay. This is a rational function, and when you have rational functions, you have asymptotes. The definition is over there, if you were not here, for asymptote. And you are going to have what is called a parabola. Creates a hyperbola, sorry. A hyperbola is what is formed when you graph a rational function, just like a parabola is formed when you graph a quadratic function. A straight line is formed when you graph a what? Linear function. Okay?
Alexis H.
Okay? So, all right. My numerator. Can I factor my numerator? No. Now, I'm not dividing, people. All I'm doing is factoring so I can find out some things. What kind of factoring is my denominator? A times C. So what are my two factors? X minus 5, x plus 3. Absolutely right. Everybody got that? Mm-hmm. Now, I'm not canceling out because I'm not dividing or multiplying. I'm just breaking it up so I can find out some things. Now, A, your vertical asymptote is where denominator equals 0. So, look at your denominator. Now, when I have a vertical asymptote, what axis is that going to hit? The x. It's going to hit the x-axis, right? So that's why it's going to be called x equals something. Now, look at... Excuse me?
You said vertical.
Yes, vertical.
Up and down.
Yes, but what axis does it hit? The x, because the x is horizontal, so it hits that. Okay? So, where is my denominator equal to 0? What x values will give me 0 in the denominator? Look at the denominator. What will make this go to 0?
Plus
5.
minus 3.
So x equals 5, and where else? Where will this go to 0?
Negative 3.
So why was that so hard? When I say where will it go to 0 means what x values do I plug in that will make this 0. So somebody should be writing down goes to 0 means what x values will make it go to 0. Okay? Now B, my horizontal asymptote. Is equal to K, which is your constant. Now, your constant would be +5 or +6 or something here. Do I have that here?
No, you don't.
No, I don't. So what is the value of my asymptote? 0. Now, if I have a horizontal asymptote, what axis does that hit? The y-axis. So this is going to be called y equals 0. Now, who can tell me when the y value is 0, what line am I on when I go horizontally? Say it. The x-axis. Because if y is 0, where am I going across at? The x-axis. Okay. Now, who remembers when we solved quadratic formulas or quadratic functions? When was the only time that we could use inverse operation? Who can remember? When b was 0, right? When b wasn't there. So, the x-intercept you can only find when k is not there. Only when k equals 0. That's the only time we can find the x-intercept. Okay? The x-intercept is where numerator equals 0. Where does this numerator go to 0, people? -5. So if I have x-intercept, how do I write that point? It's an x-intercept, so it's -5. How would I write the point for the x-intercept at -5?
X.
It would be
Oh, you said how you write the
-5.
point, so it's -5, 0.
Thank you, sir. Very good, Mr. Watson. Very good. -5, 0 is my x-intercept. Now, please look at this real quick and then ask any questions. You have to memorize these rules. Now, all you're doing is describing the graph. When we had a test, you will not have to graph this. You will have to describe the graph using these 3 rules. Okay? So tonight, you need to memorize these 3 rules. You need to go up online and watch this little lesson.
So the test will be tomorrow.
Yes.
I said the test was the next time you came to class. Okay? So, I'm going to ask again, are there any questions on this right here? All right, now the last problem is long division. We have x minus 3, 2x squared minus 5x plus 1. Okay. Now, what times x will give me 2x squared? 2x. 2x. What times x will give me 2x squared? So now I go 2 times x is what? 2x squared. Then 2 times -3 is? Now check this out. This is where you guys mess up. Leave that like it is. Now, put your subtraction sign in parentheses. Change the subtraction to addition. This is a positive 2x squared, change that negative. This is a negative, change that positive. Now, my first 2 terms cancel out. That tells me I'm on my right track. What do I get here when I add?
1x.
1x. How many terms are here?
2.
So that means I need to bring down 1 term. X times what gives me x?
1.
1. So plus 1. 1 times x is x. 1 times -3 is -3. I am subtracting. Just leave it there for now. Then change this to addition. Change that. Change that. So I have 4. So my answer is plus 4 over x minus 3.
The remainder.